Alright, day 9. This lesson is going to be a mini review. For this unit, we've worked with nth roots and fractional exponents and exponents that are not so fractional. We're going to cover it all, but this is just a mini small review. For a complete review, you can't just go by this one document. You'll have to look at other reviews, like day 10, day 11. Okay, number 1, 100. Well, first of all, I see that I have a negative power. Anytime you have a negative exponent, that tells you that you are on the wrong side of the invisible fraction. So really the first thing I would do is I would drop this down to the other side of the invisible fraction. So that is going to give you, alright, so you will have 1 over 100 to the 5 over 2 power. Now, for this problem, the best thing to do is to rewrite this into radical form, the denominator. So looking at this denominator in radical form, remember fractional exponents are always in the form power over root. Alright, power over root. So 5 is the power and 2 is the root. So this will then become the second root of 100 to the 5th power. Okay, 5 is the power, 2 is the root. Now please understand we wouldn't really write the 2. Square root, second root is understood. You don't write the 2. Anyway, so the square root of 100 we know is 10 even without the chart. So that's going to give us 10 to the 5th power. And then 10 to the 5th power using the chart is 100,000. Okay, so that's going to be 1 over 100,000. And that will be your final answer for number 1. Okay, number 2. Number 2 is already written in radical form for us, so we can just go ahead and execute. The cube root of a negative number is simply a negative number. So the cube root of 64 is 4. So that's going to immediately give us negative 4 since it's a negative number. So we have negative 4 to the 4th power. Now, when you raise a negative number to an even power, the negative goes away because the negative times the negative is a positive. So, it's just going to be whatever 4 to the 4th power is. 4 to the 4th power is 256. So the answer to number 2 is positive 256. Alright, that's the answer to number 2. Alright, once again, the best thing to do here is to rewrite this in radical form. So again, this is the power and this is the root, power over root. So here we go. So this will be the 5th root of 243 raised to the 4th power. 5th root of 243. So the 5th root of 243 is 3. So that will give us a big old 3 on the inside. Then we have 3 to the 4th power. So 3 to the 4th power is 81. So the final answer is 81. By the way, make sure you do not have a pencil in your hand right now. If you have a pencil in your hand, put it down. Okay, you need to be doing this. You can watch if you don't understand how to do something, but then you need to go back and do it yourself. If you're just copying me, you're not learning anything. Okay, number 4. Now that negative out front, it's outside of the parentheses, so it's just going to stay way out there. So don't worry about that for now. Meanwhile, inside of the parentheses, we have a negative exponent. And we all know that when you have a negative exponent, you are on the wrong side of the invisible fraction line. So this is going to become 1 over 25 to the 3 over 2 power. So now I will rewrite this in radical form. So this is going to be negative, okay, 1 over, and this is power over root. So it is the second root of 25, which will be raised to the third power. Okay. Of course, second root is just a square root. We don't put the 2. So now this is going to become, the square root of 25 is just 5. Okay, so there's my square root of 25. And then it's to the third power, so I have 5 to the third power. Notice we're doing all of this without a calculator at all. No calculator. And then we've got 5 to the third power. So 5 to the third power is 125. So this is negative 1 over 125. Alright, and that is your final answer for number 4. You will be provided with a table like this one on your test. Once again, let's rewrite this in radical form. So once again, 4 is the power and 5 is the root. Oh, looks like we're writing the word out now. So there's our 5th root, and now here is your 4th power. Okay, 5th root of 32. So 5th root of 32 is 2. So on the inside we will have 2, and then we have 2 to the 4th power. Now 2 to the 4th power is 16. So the final answer here will be 16. Now for number 6, the roots are not the same. So I'm going to have to convert this to exponent form in order to do the problem. But if it doesn't turn out to be a whole number, then I'm going to have to convert back to radical form. The rule is if you start off in radical form, you need to write your answer in radical form, unless it's just a whole number. Okay, so let's rewrite these in exponent form. The exponent, a root of 4 is the same thing as a 1/4 power. So this is going to be the same thing as having 6 to the 1/4 power times 6 to the 1/6 power. Alright, 6th root is the same thing as 1/6 power. All of this is raised to the 12th power. Now, when you multiply, you add the exponent. So this is going to be the same thing as having 6 to the 1/4 plus 1/6 power. Alright, all of that to the 12th power. So look, I need to add 1/4 plus 1/6, which I will do off to the side. So if I add 1/4 plus 1/6, the way I do that is I multiply the denominators to make them be the same. I need like denominators. So if I multiply this both of these can be turned into a 12. So I will multiply this one by 3. And I will multiply this one by 2, with the idea of making both of the denominators 12. So this would become 1 over, I'm sorry, not 1 over 12, 3 over 12, 3/12 plus 2/12. 3 plus 2 is 5, so this will be 5/12. Okay, so that is what you get when you add 1/4 and 1/6. So for that reason, on the inside here, we have 6 to the 5/12 power. And then that is raised to the 12th power. Now I could multiply 5 times 12 and get 60. Basically I'm saying I would skip this step, okay? 5 times 12 is 60, so this would be like 60 over 12. And I know that 60 divided by 12 is 5. So this would be 6 to the 5th power. Okay? But what if you didn't know that 60 divided by 12 is 5? And what if you had no calculator at all? You should still be able to do this because these 12s just cancel out. So you get 6 to the 5th power immediately. You don't really need this step. Anyway, 6 to the 5th power we can go ahead and find on the chart as well. Because 6 to the 5th power is 7,776. By the way, in previous lessons we often had said, oh, you can leave it like this. You know, anything that's bigger than 3, you can just leave it. That's not true when you have a table. Alright, if you have a table and it's on the table, you have to use the table. Makes sense? So 6 to the 5th power, you have to actually go ahead and write this out. Mandatory. Okay, so the final answer here is going to be 7,776 right off the table. Number 7. The bases are the same. If the bases are the same, you can go ahead and subtract the exponents. So this is going to become 4x to the 2 minus 1/2 power. 2 minus a half. Let's do that off to the side. So 2 minus 1/2. Well, 2 is the same thing as 2 over 1. You know we need like denominators. So let's multiply by 2's over here. Now, that's going to give me 4 over 2 minus 1 over 2. 4 minus 1 is 3, so that is 3 over 2. Okay? So that is what you get when you subtract 2 minus 1/2. So that is going to give us, in that case, 4x to the 3/2 power. Now, you see the parentheses here. Let's go ahead and do 4 to the 3/2 power and x to the 3/2 power. Okay. So, this is the way I want to do it. Yeah, this is the way I want to do it. Okay, so looking at the 4 to the 3/2 power, please understand, maybe I will do this off to the side as well. Focus on the 4 to the 3/2 power. Alright, 4 to the 3/2 power. I'm going to rewrite this in radical form. So remember, this is the power, this is the root, power over root. So this is going to become the square root, which I don't really have to put the 2 in there, but it's the square root of 4, and then all raised to the third power. The square root of 4 is 2, so that'll give me 2 to the third power, which is 8. Okay, so that is what's going to happen right here. Okay, and this happened right there. So I'm going to wind up with 8x to the 3 over 2 power. And that should be your final answer for number 7. Alrighty then, that's just genius. Number 8. When you have a power raised to a power, you multiply. So this is going to give us 125. And look, we're just doing 2/3 times 1/2. Numerator times numerator, denominator times denominator. So this will be 2 over 6, and that reduces to 1/3. So I've got this so far. Now we can do this though, because 125 to the 1/3 power is the same thing as the third root of 125. And the third root of 125 is 5. So that is the final answer for number 8, 5. And check out number 9. What is the same here? What is the same? Well, it seems like all of the exponents are the same. And if the exponents are the same, you can go ahead and multiply and divide the bases and keep this. Whatever is the same sort of stays the same. So I will do 6 times 4, and I will get 24. And this power that's the same is just going to stay the same, 2/3. And so I've got 3 to the 2/3 power. Once again, something is the same. If the exponents are the same, you can go ahead and divide with the bases. So 24 divided by 3 is 8. So now I will have 8 to the 2 over 3 power. Notice the thing that stayed the same stays the same. Alright, so now we just have to go ahead and simplify this if we can. Let's go ahead and rewrite this in exponent form. Let's go ahead and rewrite this in radical form. And you will quickly see that this can be simplified. Now 2 is the power and 3 is the root. So that means we have the cube root of 8 raised to the second power. The cube root of 8 is 2. So we have 2 to the second power, which of course is 4. And that is the final answer, 4. Number 10. The roots are not the same. So I cannot multiply the bases. But I can do something. What can I do? Well, see there, the 7s are the same. I could do something if I wrote this in exponent form. So a problem like this, you really want to go ahead and write this in exponent form. Now, if necessary, unless this simplifies down to a whole number, we will have to turn it back into radical form at the end. Fourth root is the same thing as the 1/4 power. Fifth root is the same thing as the 1/5 power. Now we can do something. Since the bases are the same, we can add these exponents. So what we're dealing with is 7 to the 1/4 plus 1/5 power squared. Now off to the side, I'm going to do this addition. So 1/4 plus 1/5. Okay, I guess making these both into 20 is the best we can do. So multiply these by 5 and multiply these by 4. So that's going to give us 5 over 20 plus 4 over 20. So that is 9 over 20. Okay, so that means we have 7 to the 9/20th power squared. Alright, so that is going to give us 7 to the 18 over 20 power. And this will reduce to 7 to the 9/10 power. Now, that's as far as this will go. Now, remember, like I said, since we started off in radical form and this doesn't simplify any further, we need to turn this back into radical form. Now, we're not allowed to have any parentheses in here, so we're going to have to use this form. 9 is the power, 10 is the root. So obviously we're going to do 10th root of 7. But let's go ahead and tuck the 9th power right in there. That way we don't need any parentheses, which are against the rules. Okay, so there you go, simplified form. The 10th root of 7 to the 10th power. Kabam. I'm sorry, 10th root of 7 to the 9th power. Just let me emphasize one more time that you can't write it in this form like this. Okay, this is no good because we're not supposed to have parentheses in our final answer. So use this form instead of this form. Okay, how about that number 11, ladies and gentlemen? If you have the cube root of a fraction, that is the same thing as having the cube root of the numerator and the denominator separately. So let's go ahead and do that. Alright, now I'm loving the denominator here because the cube root of 1000 is 10. Alright, so that's just going to straight become a 10 down there. Bada bing, bada bang. Now, the 16 though, cube root, there's no 16 on this list. And the only thing that could possibly divide into 16 is 8, which is on the list. So I am going to go ahead and split this up. Alright, I'm looking at the 16, I'm looking at you 16, and I'm going to split up 16 as 8, okay, times 2. Alright, that makes your 16. Okay, I'm going to wrap this around. Now, this pink number is going to come outside the radical and simplify. So the cube root of 8 is 2. So that's what's happening here. So this 8 is going to become a 2 outside the radical. Alright, so I've got 2. Now the blue part is just going to stay like it is. Alright, the cube root of 2 and even the 10 that's in the denominator. So I've got this so far. Now you must reduce these for full credit. Alright, so what's happening is 2 goes into itself once, 2 goes into 10 5 times. So that gives us the final answer of the cube root of 2 over 5. Alright, how about number 12? See, we're doing the fourth root, people. Now this stuff in the front is just going to hang out for a while. So I've got 10a to the third power. That's great. Now, let's see, is 48 on the list of the fourth power? No. let's see, does 16 go into 48 evenly? It does, I know this, but just in case you do not know this, 48 divided by 16 is 3, which means that 16, hold on, it's supposed to be 16 times 3 is 48, of course. So I am going to use that knowledge to break things up in here. So I've got my fourth root. Now I'm going to split up the 48 as 16 times 3. Alright, I'm writing the 16 in pink because I can simplify the fourth root of 16 and I can get 2. Now as far as the variables, I need this exponent to be divisible by 4. So I'm going to have to split this up as well. And all I can do is write a to the fourth power, because that's divisible by 4. And then that's going to leave 2 a's left over, a squared. Okay, so everything here in pink is going to simplify and come out. So the pink stuff first, the fourth root of 16. As we discussed, the fourth root of 16 is 2. So that's going to be 2. Alright, the fourth root of a to the fourth power is a. I'm just doing 4 divided by 4 is 1. Now everything in blue is just going to stay the way it is. So I will have the fourth root of 3a squared. And also this blue over here is going to come down. So I've got 10a to the third power. And that's multiplying by times the stuff I just brought out. So 10 times 2 is 20. Alright, a to the third times a is a to the fourth power. And then the fourth root of 3a squared. There it is, people. There's number 12. Alright, what's up with number 13? What's up with number 13? I got the sixth root and stuff. Yeah, about that. The 6. Nothing I can do with that. It's too small. So that's just going to stay 6. Now x to the 6th power, loving that, because 6 is divisible by 6. 7 is not divisible by 6. So I'm going to have to split this up as y to the 6th power with 1 extra y left over. Together they make 7. Z, also going to have to split this up as z to the 6th power. Alright, that's the first number below 10 that is divisible by 6. And that's going to leave 4 little z's left over. Okay, because together that's 10 z's. So as you've seen before, everything here in pink can simplify and come out. 6 divided by 6 is 1. So this x is going to become just x. Y to the 6th power will simplify to y, and z to the 6th power will simplify to z. So that's it for the pink stuff. Everything here in blue is going to stay exactly like it is. So I will have the 6th root of 6y z to the 4th power as my final answer. Alright, check it out. All of these roots are the same. They all show no number sitting here, which means that they are all the second root, square root. Because the roots are the same, you can go ahead and multiply and divide if you want to. So let's do that. Let's start by multiplying these together right here. So that 3 is just going to sit there. Now x times x to the 3rd power is x to the 4th power. Now, meanwhile, down in the denominator, I have the square root of 25x to the 10th power. Now look, everything under the radical can actually be simplified. Alright, I could make all this stuff in pink if I wanted to. So we can go ahead and simplify those things. So the square root of x to the 4th power, remember, even though it's not showing, square root is like an invisible 2 right here. So because we got 4 divided by 2 is 2, then I will have x squared. Alright, it's not because I'm taking the square root of 4, it's because I'm dividing by 2. And no more radical. Same thing down here. Now, forgetting the x for a second, this is the square root of 25 is 5. And then for the variable, you divide by this invisible 2. So 10 divided by 2 is 5. So this will be x to the 5th power. Now this is not the end of the problem. You should be able to do this in your head. But in your head, you should be picturing this is 3, and x squared is like having x times x. And down here, this is 5. And then x to the 5th power is like having 1, 2, 3, 4, 5 x's. Now, these two x's are canceling out 2 of these x's. And that leaves behind 3 x's. So that's why the final answer is going to be 3 over 5x to the 3rd power. Okay, a negative exponent and a 6, and we got all these roots. So much to do, so much to do. Where to begin? Well, let's work from the inside out. I'm always looking for what's the same. What's the same? Do you see anything that's the same? The roots are the same. Cube root, cube root. If the roots are the same, you can combine these. You can multiply the stuff on the inside. So I have 6 times, but I can put these two together. So this is what's happening right now. So I will get the cube root of x to the 9th power to the negative 3. Okay, when you multiply variables, you add those exponents. So 9. Now I can go ahead and simplify the cube root of x to the 9th power right now, because 9 is divisible by 3. So this is going to give me, there's my 6, but then I'm going to have x to the 3rd power. 9 divided by 3 is 3. Alright, now all of that is still to the negative 3 power. Now, when I have a regular number here, here's what I like to do, especially when there's a negative exponent. For a moment, I just stick the negative power on there. 6 to the negative 3 power. Just let it sit there. Now these you multiply. So I'm going to have x to the negative 9 power. But now I look and ask myself, whoa, wait a minute. What do I always do when I have a negative exponent? And by now you should be masters of this. Anything with a negative exponent must get moved to the other side of the fraction. So in other words, both of these are going to have to drop down. Okay, and that is why the final answer is going to be 1 over, you know what, I'm going to put it here, 1 over 6 to the 3rd power x to the 9th power. Wait a minute, did I say final answer? Slow down. Well, I am going to do one more thing. Since we have the table and all, we can go ahead and do 6 to the 3rd power, even without a calculator. So if you have the table, always do everything out in terms of a number and a power, like 6 to the 3rd power. 6 to the 3rd power is 216. So I will go ahead and write 1 over 216 x to the 9th power. That will be the final answer. Alright, y'all, that was the last problem. I hope it was helpful, and I will see you on the next video.